This is the second video in the chapter Algebra 2, Chapter 2.8, Solving Absolute Value Equations and Inequalities. And I want to refer you to this chart, which I believe is on the second page of your note guide. We spent the first video solving absolute value equations, and you would isolate the absolute value equation, then you would set it equal to the a, which is here, and then you'd set it equal to the negative a, which is here. We're going to do the same thing with inequalities. So these are the two different versions. You can have less than or equal to. Those imply and problems, conjunctions. Or you could have greater or greater than or equal to, and those imply or problems. And you simply isolate the variable. You write it the way you see it without the absolute value signs, and then you write it the way you see it on the left side. You flip the inequality sign and you negate the a value. Same thing with here. You write it the way you see it without the absolute value signs. Then you flip the inequality signs and negate just the a value. So we're going to complete the second page, actually the third page. So the first step is, just like solving an equation, is to isolate the absolute value expression. You want to make sure you do not distribute into the absolute value symbols. So we're going to divide both sides by 4 to get the absolute value of x minus 8 is greater than 3. So we can see that this is an and problem, or excuse me, it's an or problem, or if you get greater than or greater than to equal to. So most likely the shading will go in opposite directions. More is or. So now we're going to split it up. We're going to write it the way we see it without the absolute value signs, just like I've done here. Then we're going to write it the left side the way we see it. We're going to flip the inequality sign and we're going to negate the value on the right. And then we go ahead and solve both inequalities. So this one we get x is greater than 3 plus 8. X is greater than 11. And again, this is an or. X is less than negative 3 plus 8. X is less than 5. So we are going to graph this, and then we'll do a test value to see how it works. So x is less than 5. Well, 5 would be on this side. Open circle shading to the left. 11, open circle shading to the right. So anything in the shaded region is a possible solution. So I'm just going to pick a number 0, and we're going to see if 0 is a possible solution. And I'm going to put it in to the original inequality sign and see inequality and see if it works. So the absolute value of negative 8 is 8, and then 8 times 4 would be 32. So 32 is greater than 12. So we've picked, that one's right. And then we could pick one on this side as well and show that it's also a solution. So the key here is splitting the problem. Write it the way you see it with the absolute value sign, and then write the left side the way you see it, flip the absolute value sign, and negate the number, because we know absolute value can be positive or negative. We're going to do another one. This one is going to require an and. So if there's a less than or less than equal, that means it's an and problem, a conjunction, and we are going to satisfy, the solution has to satisfy both shading. First thing we do is isolate the absolute value expression. Never want to multiply into the absolute value. I'm going to undo the division of 2 by multiplying both sides by 2. So get the absolute value of x minus 5 is less than or equal to 8. Now I'm going to split the two equations. I'm going to write it the way I see it with the less than or equal to 8, and then I'm going to flip the inequality sign and negate. This is where people make the mistake. Write it the way you see it, then write the left side again, flip the absolute value sign, and negate. Then you want to solve both inequalities. This will give you 8 plus 5. X is less than or equal to 13. This one will give you x is greater than or equal to negative 3. Again, it's got to satisfy both inequalities, but I'm going to shade graph both. X is greater than or equal to negative 3 would go in this direction with a closed circle. I'm going to do this one in a different color. X is less than or equal to 13 would be shaded, closed circle and shaded to the left. And remember, the final solution is where the two overlap. So negative between -3 and 13, including those two numbers. And if we were to write that using interval notation, it's any number from -3 to 13. So let's do a test value. I always like to test 0 because 0 is, if possible, 0 is easy to plug in. So I'm plugging 0 into the original absolute value equation, and I'm just going to see that the left side equals, or it's true, not equals. Absolute value of -5 is 5. 5 has is indeed less than or equal to 4. So we have solved it. You guys, the key to solving absolute value equations and inequalities is splitting the problem into the two. Make sure you review that over and over and over. On the next side is practice B. I have put the answers up only for practice B. You need to solve these on a separate sheet of paper, and then you need to make sure that your answers check with mine. But again, you've got to solve these on a separate sheet of paper because there's just not enough room. And there are my solutions. Then your homework is problem set 2.8, page 154. Most of these are odds except for number 4. Be sure you check your answers in the back of the book and you submit. Hopefully this will help, and we will talk more about it next class.